Hello to you watching this video. So for this video, we're going to discuss about module number 9, Control Survey. So this module will give you an introduction to control surveying, explain and illustrate how to compute triangulation and trilaterization. Okay. So what is control surveying? So control surveying is the determination of precise position of a series of stations distributed over an area to serve as a origin or reference to be used for checking of subsequent surveys, to be used in engineering projects like property delineation, topographic and hydrographic mapping, and construction planning and design. So, control surveying will give us the specific location of certain points that we want to know. Where is it located? Okay, so bibigyan niya tayo ng coordinates. Okay, so or coordinates or specific locations. So control networks which cover the whole country have become conducted with better accuracy and less stringent technique with the use of artificial satellites. So these stations are linked to local networks which have been adopted for special surveys connected with projects such as dams, roads, railways, and pipelines, large and small construction sites, and etc. So control networks will helps us pinpointing the exact location of these specific structures with the help, of course, of technology. Okay, so yung mga yan is like for example, uh, hindi siguro familiar iba pero I believe karamihan sa atin we were able to see na Google Map. So sa Google Map, nabibigyan tayo ng direction, nabibigyan tayo ng coordinates, yan. So it gives us specific location. So that is a product of control surveying. Okay, and a different combination of technology. So the purpose of a control system is to prevent the accumulation of errors by connecting detail work to a consistent geometrical system of points, which are accurate enough for the project. Great care is taken to ensure that this control is sufficiently accurate. Okay, so I repeat, it should be accurate. Okay, so there was a time when geodetic control points consisted of triangulation networks marked by observation pillars. In the Philippines, many triangulation stations have been located on top of towers, which had been placed on mountains summits to answer the problem of intervisibility. So if you can observe sa mga province, isn't it that sa mga hindi matataong lugar, there are towers. Okay? So may mga towers lalo sa mga province, yung mga medyo bundok sa mga province. We have towers there. So, yan. So, isa yun sa mga naglalagyan dito sa specifics sa Philippines for intervisibility, to answer the intervisibility problem. Okay? But because of the ease with which positions can be established by satellite systems, which eliminated the intervisibility requirement, there has been less need for establishing so many points. Gradually, as the scope of the survey becomes smaller, the use of non-satellite systems to provide control becomes more prominent. Hindi lahat ng tower, by the way, na nakikita natin sa province are ito yung satellite system. Okay? Meron kasi yung ibang mga tower for communications. Okay? So, hindi lahat. So, what we are trying to say here is that yung mga nilalagay natin yung pinaglalagyan natin ng mga satellite towers natin is sa mga hindi matataong lugar and medyo mataas. Okay? Then, gradually, as the scope of the survey becomes smaller, the use of non-satellite systems to provide control becomes more prominent. Control underground, in urban streets and inside building is predominantly carried out by terrestrial methods. Apart from their use with further ground survey operations, control points are also required to augment photogrammetric and remote sensing methods of mapping. So photogrammetric is the usage of photography aerial survey. Okay, plan coordinates and heights of points identifiable on imagery are needed by all but most sophisticated systems. Okay, horizontal control points techniques. Letter A, triangulation, or it is the usage of trigonometric intervention. Okay, or it is also called the trigonometrical survey. So in the past, it was difficult to accurately measure very long distances, but it was possible to accurately measure the angles between points many kilometers apart, limited only being able to see the distant beacon. This could be anywhere from few kilometers to 50 or more. So yes, so this is one of the advantage of triangulation. We can compute, or we can use trigonometrical survey for a distance where you have few kilometers to 50 kilometers or even 50 kilometers more, because again, we use the help of trigonometry. So triangulation is a surveying method that measures the angles in a triangle formed by three survey control points. So I repeat, it is a survey method that measures the angles in a triangle formed by three survey controls. So if it is not triangle, then we cannot use triangulation. So using trigonometry, and the measures length of just one side and the other distances in the triangle are calculated with the help of sine law and cosine law. So the shape of the triangles is important, as there is a lot of inaccuracy in a long skinny triangle, but one with the base angles of about 45 degrees is very ideal. Okay, so each of the calculated distances is then used as one side in the other triangle to calculate the distances to another point, which is in turn can start to another triangle. So this is done as often as necessary to form a chain of triangles connecting the origin points to the survey control in place needed. So it is a chain of triangles. So we can start with one triangle, then magiging dalawang triangle, magiging tatlong triangle, until makuha natin yung gusto nating makuhang data. Okay? So it is a series of triangle or a chain of triangle. So the angle and the distances are then used with initial known points and the complex formulae to calculate the position, latitude, and longitude of all other points in the triangulation network. Although the calculations used are similar to trigonometry taught in high school, because the distance between the survey points is generally long, the calculations also allow for curvature of the Earth. So if the distance is already long, is already far, no, or already big, we need to apply the correction due to Earth's curvature and refraction, like what we have in our previous module. So the measured distance in the first triangle is known as the baseline and is the only distance measured. So yung baseline natin, yun lang ang mini-measure. Okay? Wala tayong wait. So baseline, ibig sabihin yung uunahin nating measure. Okay? So all the rest are calculated from it and the measured angles. Prior to 1950s, the initial baseline distance would have to be very carefully measured with successive lengths of rods whose length were accurately known. This meant that the distance would be relatively short, maybe a kilometer or so, and it would be a reasonably flat area such as a valley or plain. So it is very ideal if it is flat. That is to maintain accuracy, because we are measuring, take note, horizontal distances. Okay, but if it cannot be avoided, then appropriate correction should be applied. Okay, So the triangles measured from it gradually increased in size and up onto the hilltops where distant points could be seen easily. Okay, so we have here the known positions. We have here known position of the red line, and we also have a measured angle. Then from there, we already start our calculation. So we have a calculated distance. And then from there, we can get another triangle here. Then from there, we can well, no. It is a calculated distance. Yeah, tama. We can create triangles, series of triangles. Then from there, we can now determine our desired data. Take note, ito lang ang mineasure natin. Measured angle here, and measured distance. Okay? So from there, we had a series of distances. Okay? So, triangulation network. Ito yun, figure 1. Okay? Angles in the triangles are measured using a theodolite, which is an instrument with telescope connected to two rotating circles, one horizontal and one vertical. Unfortunately, we were not able to conduct this experiment or experiment fieldwork or try at least to use a theodolite or calibrate a theodolite because of the pandemic. So hopefully, during your higher years or in the field, you can encounter this and try to learn on how it works because it will really help quite. It will quite help you in the future in the field. Okay, so yeah. The measure of horizontal and vertical angles. A good quality theodolite used for geodetic surveys would be graduated to zero point 0.1 second of an arc, and an angle resulting from repeated measurements would typically have an accuracy of about 1 second of arc, which is equivalent to about 5 centimeter over a distance of 5 kilometers. So, steps in triangulation. First, we have the reconnaissance. So, reconnaissance, ibig sabihin, we need to study uh, carefully the environment, then titignan natin if it is feasible, kung saan yung mas magandang i-measure. Yeah. So, saan mas feasible mag-measure. So, next would be measurement of the baseline. Letter C, erection of signals and towers. Letter D, measurement of angles. Letter E, astronomic checks. And lastly would be the office computations. Okay? Take note, etong mga distance na to, magkakalayo yan. So, if you're going to have a continuous measurement, imagine kung kailan ka pa matatapos. Okay? So, that is the advantage of this method. Okay? Letter B is trilateration. So, in 1950s, accurate methods of measuring long distances, typically 30 to 50 kilometer, were deployed. They used the known speed of light. So 299,791.458 kilometer per seconds. So that is the speed of light. And the time reflection of a microwave or light wave along the measured line, known as electromagnetic distance measurement or EDM. The two initial types of instrument were the teleurometer, which used a microwave, and geodiameter, which used a light wave. So the distances in a triangle could then be measured directly instead of calculating them from the observed angles. So if needed, the angles could be calculated. The process of calculating positions through the chain of triangles is then the same as the triangulation. So some both angles and distances were measured in some triangles to check on the observation and improve the accuracy of calculation. Okay, so it is almost the same. So you have here a known position. So you have measured distance, measured distance, measured distance, measured distance, measured distance, calculated position, and so forth. Okay. Okay. So we have here our illustrative problems. Okay, so we have here the illustrative problem. In a triangulation, an eccentric station is occupied instead of the true station A. Observations then are made to true station A and station B. The observations are as follows. When we say eccentric, it is not placed centrally. Therefore, when we say true A and B, this is the true location. Okay? When we say true A, yan yung true location natin. So, the um, we are to find the azimuth of line AB. So, true A and point B. So, we need to determine the azimuth. So, the first thing that we need to do, of course, is to plot. So, we have eccentric A to B. Okay, so from eccentric A to B, we have here 158 degrees, 30 minutes, and 50 seconds. So from the south, going here, this is your azimuth. This is the azimuth of eccentric A. So more or less, it looks like this. So this is 158. So 158 degrees, 30 minutes, and 50 seconds. Okay. Then we have here, this is your eccentric A. Then this is your true A. Then from eccentric A again to B, from eccentric A to B, it is 216 degrees. So 90, 180. Then we have 216 degrees, 43 minutes, 20.5 seconds minus 180. So that is 36. Okay, so from the south, it is 36, from the north, it is 36 going east. So let's say this is your uh, eccentric A to B. So this is your point B. And it has a distance of 18,642 meters. While the eccentric A to A, you have a distance of 4.5 meter. Okay. So the true line AB is unknown. So we need to determine your line AB. Here, let's determine the interior angle. So we have here 150 minus 80. So ito alam na natin to. This angle here is equivalent to 36 degrees, 43 minutes, 20.5 seconds. Okay, so alamin natin yung ito. So we have 180 minus 158 degrees, 30 minutes, and 50 seconds. And that is equivalent to 21. The angle here is equivalent to 21 degrees, 29 minutes, and 10 seconds. Okay? So, then we can use here cosine law. Why? Because we have two sides known, one side unknown, and we have one unknown, known angle. Okay? So, we can have here line AB. So, using cosine law, we have line AB squared is equivalent to 4.5 squared plus 18,642 squared minus 2 times 4.5 times 18,642 cosine of this angle, and the angle is equivalent to, what is that angle? We have 36, 43, 20.5 plus 21, 29, 10. Therefore, the interior angle for this, the angle on this side is equivalent to 58 degrees, 9 minutes, 30.5 seconds. Okay, so line AB is equivalent to, with that we get the square root. So 4.5 squared plus 18,642 squared minus 2 times 4.5 times 18,642. Cosine of 58 degrees, 9 minutes, 30.5 seconds. And that is equivalent to 18,639.63 meters. Therefore, the length of line AB is 18,639.63 meters. But we're not yet done. We need to determine the azimuth. What would be the azimuth of this line? Okay, so from the south going here. Okay, so using sine law, we can get the angle here. Let's say this is theta A. Okay, so sine, we have the opposite side, which is 18,642 over sine of theta A is equivalent to, we have this side and we have this distance, and the distance AB is 18,639.63 meters. So we have 18,639.63 meters divided by what is sine A, with sine of this angle, which is 58 degrees. So sine 58 degrees, 9 minutes, 30.5 seconds. So cross multiply, we will be having here theta, cross multiply, we will be having 18,642 sine 58 degrees, 9 minutes, 30.5 seconds divided by 18,639.63 shift arc sine. Okay, so theta A is equivalent to we have 18,642 sine 58, 9, 30.5 divided by 18,639.63, and that is equivalent to 58 degrees, 10 minutes, 12.74 seconds. Okay, now to get the azimuth, we have here the azimuth first of line AB, and the azimuth of line AB, A to eccentric A, is, we have here 58 degrees plus 180 para makuha natin yung azimuth. Kasi this is yung azimuth na 158 is from eccentric A to true A. This time it is true A to eccentric A. So we add 158 degrees, 30 minutes and 50 seconds. So azimuth of A to eccentric A is equivalent to 180 degrees plus 158 degrees, 30 minutes, 50 seconds. So 180 plus 158, 30, 50. So that is equivalent to 338 degrees, 30 minutes and 50 seconds. Now we need to determine the azimuth of AB. So azimuth AB is equivalent to 338 degrees, 30 minutes and 50 seconds minus, okay? So this time, ang gagawin natin para mas mabilis, we subtract the remaining interior angle aside from the angle that it is involved, no? Dito ang involved is theta A. So isusubtract natin yung theta A sa interior angle ng triangle na to, which is 180. Then yung remaining is yun yung isusubtract natin sa azimuth reference natin, which is this, okay? So azimuth A to eccentric A minus the interior angle of theta B and this one. Okay, so we have here 180 degrees minus 180 degrees minus 58 degrees. Yeah, 58 degrees, 10 minutes, and 12.74 seconds. Therefore, azimuth AB is equivalent to 338, 30, 50 minus 180 minus 58, 10, 12.74. And our azimuth AB is equivalent to 216 degrees, 41 minutes, 2.74 seconds. So that is azimuth AB. Take note, hindi dapat masyadong magkalayo yung azimuth ng eccentric AB and 216 degrees or rather yung azimuth ng AB. Why? Because take note, 18,642 meters versus 4.5 meter is very small. So, sobrang liit lang yung magiging difference ng angle. So, the angle should not be far from each other. Okay? Okay, so we have here problem number 2. The lengths of sides of triangles ABC as measured with an EDM instrument are AB, which is 923.245 meter, BC is 517.328 meter, and CA is 896.126 meter. The azimuth from the south of side CB is 340 degrees, 15 minutes, 20 seconds, and the coordinates of station B are XB 10,150.22 meter, and YB is equivalent to 9,450.085 meter. So assuming that the lengths are free from systematic error, so there were no error measured, determine the following preliminary data which are to be used in subsequent adjustment by trilateration. So what we have said earlier, isn't it, that for this subject or for this module per se, we are going to be solving for coordinates, specific locations, okay? So let's try. So we need to determine the interior angles, the azimuth from the south of sides A, B, and CA, and the coordinates of point AC. Okay, so first we need to determine the given or plot the given. Ano ba yung given natin? So CB is drawing natin. So we have our then CB is 340 degrees 15 minutes from south. So this is 200 290 180 270 and 340. It is located here. So this is the azimuth of line CB. So this is point C, this is point B, and it has a degrees of 340 degrees, 15 minutes, and 20 seconds. Okay? Now, next, B has a coordinate. So, XB is equivalent to 10,150.022 meters, while YB is equivalent to 9,450.085 meters. Okay? So, assuming that the lengths are free from systematic error. Okay. So, next is we have as measured, wala na. So, yun lang ang binigay sa atin. Okay? So, ang gagawin natin is we assume. Okay? We assume the direction of line AB and BC. Okay? So, let's say this is AB here. And we have here BC, which is, let's say, this is BC. Okay? No, AB and AC rather. So, BC has a distance of 517.328, while AC is 923.245 meters. And AB here is equivalent to, mali. AC is equivalent to 896.126 meters. And dito is 923.245 meters. Okay. So, we can solve the angles using cosine law muna because we do not have any interior angle. But if we're going to use cosine law, we can solve for at least one. Then from there, we can use sine law. Or we can proceed with the computation of other angles using cosine law. So using cosine law, we have a squared is equivalent to b squared plus c squared minus 2ab cosine of a. Okay, so we have here, let's say we are looking for the angle here. Okay, para mas madali natin. Yeah, actually, we're going to solve it anyways. So, let's say this is theta C. Let's say this is theta A. And let's say this is theta B. Okay? So, we have here, ayusin na natin. Ang hinahanap natin is si theta A. So, transpose this to the other side of the equation to make it positive. So, we have b squared plus c squared transposed to the other side, so that would become a negative, is equivalent to 2ab cosine theta a. Okay, so cross multiply, cosine theta a is equivalent to b squared plus c squared minus a squared divided by 2ab. Arc cosine, so that would be theta a is equivalent to arc cosine b squared plus c squared minus a squared over 2a. No, that's 2bc dapat. This is bc. Kasi itong side na to yung given. No, that should be bc. So 2bc, 2bc. Okay? So substituting the value, theta a therefore is equivalent to arc cosine. What is b? B is this side. So this is side A na pagbaliktad natin. Anyways, this is ang angle natin, ito yung hinahanap nating angle, theta A. Therefore, this is A. This is A side, this is B side, this is C side. So, B is equivalent to 896.120 plus the C side. Ano yung C side natin? Ito. Plus 923.245 divided by 2 times 800, this is squared, 896.126 times 923.245. May kulang tayo sa numerator. We have A. A side natin is 517 squared, 517.328 quantity squared. Therefore, theta A is equivalent to we have 896.126 squared plus 923.245 squared minus 517.328 squared divided by 2 times 896.126 times 923.245. And that is equivalent to 32 degrees. Theta A is equivalent to 32 degrees, 59 minutes, 46.95 seconds. Okay? Now, since we already have one angle known, we can use sine law. Mas madali kasi pag sine law rather than cosine law na transpose and cross multiply tayo. So using sine law, I have here theta A. So the opposite side is 517.328 But the advantage of using cosine law, if your first computed angle is incorrect, yung mga susunod na angle na masosolve mo, pwede pa rin tama. But for sine law, if your first computed angle is incorrect, then yung mga susunod na angle is incorrect. So that's why you need to double check it. So the opposite angle is sine 32 degrees, 59 minutes, 46.95 seconds is equivalent to 896.126 divided by sine theta b. So theta b, we can have it directly with our calculator. 517.328 divided by sine 32 degrees, 59 minutes, 46.95 seconds is equivalent to 896.126 divided by sine alpha x, and theta b is equivalent to, let's just wait for it. But if you want a faster solution with respect to the angle, you can simplify your equation. Okay, so i-simplify natin para sa magka-idea yung iba. So we have sine theta b is equivalent to 896.126 cross multiply sine 32 degrees, 59 minutes, 46.95 seconds divided by 517.328. Now, arc sine, that would give us theta b. So, theta b is equivalent to arc sine 896.126 sine 32 degrees, 59 minutes, 46.95 seconds divided by 517.328. And yeah, that is 70 degrees, 37 minutes, and 14.65 seconds. So for the third angle, you can use sine law or cosine law again, or we can use the sum of the interior angles minus the two sides. So for theta c is equivalent to 180 degrees minus 70 degrees, 37 seconds, 14.65 minutes. 14.65 seconds minus 32 degrees, 59 minutes, 46.95 seconds. And that would give us our answer. So 180 minus 70.37.14.65 minus 32, 59, 46.95. And we have here 76 degrees, 22 minutes, 58.4 seconds. And that is theta c. So we were able to solve our three interior angles. Next would be determine the azimuth. Okay, determine the azimuth from the south of sides AB and side CA. So A to B, C to A. So yeah. Okay, so let's solve for the azimuth of south from the south of sides AB and C to A. Okay, please do not be confused with the orientation. So here we have C to A and we have A to B. So the interior angle of theta C will the interior angle of theta C is equivalent to 76 degrees, 22 minutes, and 58.4 seconds. Now, if we're going to subtract the theta C, it will already give us the azimuth for C to A. Kasi mag-stop na doon yung angle natin. So, right away, it will give us the azimuth of C to A. So, azimuth of C to A is equivalent to 340 degrees, 15 minutes, 20 seconds, minus theta c. What is theta c? Minus 76 degrees, 22 minutes, 58.4 seconds. Therefore, azimuth C to A is equivalent to 340 degrees, 15 minutes, 20 seconds, minus 76, 22, 58.4. So that is equivalent to 263 degrees, 52 minutes, 21.6 seconds. So that is azimuth of C to A. Next, okay? Next would be the azimuth of A to B. Okay, so what we're going to do is, isn't it that we already got the azimuth for C to A? We are going to get the bearing of this from C to A para makuha natin yung A to C. Then, isusubtract natin yung interior angle ng A. Then, that would give us the azimuth for A. Okay, so let us redraw. If this is point A, this is angle this is A to C. Okay, so this is C. Then, this is interior angle theta A. Then, if we already have the azimuth from A to C, right? So, isusubtract, we are going to get the bearing. Then, yung angle dito, the angle here, so let's say that's lambda, is equivalent to lambda here. So, lambda minus theta A, that would give us the azimuth. Azimuth A, B. Okay? So, for C, bearing of C is equivalent to, that is equivalent to 263. Tama ba? That is 200, ito. So, 263 degrees, 52 minutes, 21.6 seconds. So, for the bearing therefore is equivalent to 263 degrees, 52 minutes, 21.6 seconds, minus 180 degrees. Therefore, the bearing is equivalent to 83 degrees, 52 seconds, 21.6 minutes. And that is from south to east. No. That's from north to east. Now, if we are coming from A, that is equivalent to south going west. So, south, 83 degrees, 52 minutes, 21.6 seconds west. Okay? That is the bearing of line AC. So, from there, makukuha na natin yung azimuth AB. So, azimuth AB is equivalent to 83 degrees, 52 minutes, 21.6 seconds. Yung angle natin dito. Then, we subtract theta A minus theta A. So, we have 83 degrees, 52 minutes, 21.6 seconds minus theta A, which is 32 degrees, 59 minutes, 46.95 seconds. Therefore, the azimuth is equivalent to 32, 59, 46.95 is equivalent to 50 degrees, 52 minutes, 34.65 seconds. So that is azimuth AB, okay, from the south. Next, we determine the coordinates of points A and C. To solve for the coordinates, we need first to determine the latitude and the departure of AC and AB. Okay? No. CB and AB. Okay? So, first is, so this is A here, this is B, and lastly, we have letter C. Now, we need to determine the latitude versus the latitude and departure. So, latitude AB is equivalent to, take note that latitude is the vertical. Okay? So, i-redrawing natin, that is AB. So, AB looks like this. And it has an azimuth of, wait, what is our azimuth? 50 degrees. 50 degrees, 52 minutes, 34.65 seconds. So, this is A, B. Okay? So, latitude is, it is the vertical latitude departure. And we are in reference with the north and or south. So, we are going to use cosine. So, anong distance ni AB? AB is equivalent to 923.245 cosine 50 degrees, 52 seconds, and 34.65. 34.65 seconds. Okay. Next would be departure of AB, and that is equivalent to 923.245 sine 50 degrees, 52 minutes, 34.65 seconds. Okay. Next would be for the latitude of CB. Now, for CB, i-redraw natin yung ating okay, so this is C, and this here is B. Okay, so ano ang azimuth natin dito? So, we have here 340 yung azimuth natin, but we need to get the bearing. The bearing is equivalent to 360 minus 340, 15, 20. And that is equivalent to, the bearing therefore is equivalent to 19 degrees, 44 seconds, 40 minutes, 40 seconds. So, latitude CB is equivalent to, anong distance natin? 517. So, 517.328 cosine of angle 19. No. Cosine 19 degrees, 44 minutes, and 40 seconds. Next would be the departure. So, departure CB is equivalent to 517.328 sine 19 degrees, 44 minutes, 40 seconds. Okay, so solve natin yung mga value. 923, 245, cosine 50 degrees, 52, 34.65. And that is equivalent to 582.565 meters. Then yung isa is sine. That is 716.240 meters. Okay. Next, 517.328 cosine 19 degrees, 44 minutes, 40 seconds. And that is equivalent to 486.914 meters. Then, palitan natin yung sine into cosine, yung cosine into sine. That is 174.767 meters. Now, take note, for B, we have the coordinates. For x of B is equivalent to 10,000. 10,150.022 meter. And x sub y, y sub b is equivalent to 9,450.085 meters. Okay? So, to get the coordinates, okay, so for XA, x of a, we simply we simply copy the value of the latitude and we add it or subtract it to the coordinates of xb. So xb here is 10,150.022. Now, i-check natin. Is xb on the x-axis? On the x-axis, is it to the right or to the left? If it is to the right of x, it is plus yung location ni A. Pag yung location ni B is to the left of xb, then we subtract. Okay? Now dito, si x of A is located to the right of x of B. Therefore, i-add natin yung departure ni x sub A. Okay? So the departure of AB is 716. So plus 716.240 meters. Next, for y sub A, let's check. So this is y sub B. If y sub B is, if y sub A is above y sub B, we are going to add the latitude. If y sub A is below y sub B, isusubtract natin si 716. Okay? I repeat. If if the latitude of A ay nasa taas ni coordinate B, we are going to add it. If the latitude of A is below B, then we are going to subtract. Dito, si latitude ni A nasa taas ni y sub B, therefore i-add din natin. Okay? So we have here 9,450.085 plus the latitude of 582.565 meters. Next, we have x sub C. Now, this is point B. Is x to the right or x sub C or yung if that is the departure of C to the right of B or to the left. Pag nasa left siya nung reference natin, which is si B, isusubtract natin yung x or yung departure. So, ito si B and the coordinate of B is 9,450.085 and nasa left yung x or x coordinate, not x coordinate, yung latitude ni C, yung departure ni C. Therefore, we're going to subtract. So C is minus 174.767 meters. Now we have here y sub C. Now, is y or the latitude of C above B? If it is above the reference, we're going to add. If it is below the reference, we're going to subtract. Our reference here is B and mali ito. This should be 10,150.022. Now, balik na tayo. We have here y. YB is our reference. Then x, y of C is to the is upwards. Therefore, nasa taas. So, we're going to add. So, 9,450.085 plus the latitude of C. Latitude of C is equivalent to 486.914 because it is above the reference. So, we can now solve for the coordinates. So, 10,150.022 plus 716.240 is equivalent to 10,866.262 meters. 9,450.085 plus 582.565 is equivalent to 10,032.65. Okay? Next would be this. So, we have 10,150.022 minus 174.767. That is equivalent to 9,975.255. And we have here 9,450 plus 480, 085 plus 486.914. So 9,936.999. Okay? There is a way to check whether our answer is correct. Okay? So using the distance formula, so x2 minus x1 squared plus y2 minus y1 squared, then get the square root. Okay? So kunin natin si AB. So si x ni A, so line AB here is equivalent to, we have xb minus xa quantity squared plus yb minus ya quantity squared. So this is the distance formula. So the square root of what is xb, we have 10,000, 10,150.022 minus what is x sub a, we have 10,866.262 quantity squared plus YB. YB is 9,450.085 minus Y sub A, which is 10,032.65 quantity squared. Okay, so let's check the square root of 10,150.022 minus 10,866.262 quantity squared plus 9,450.085 minus 10,032.65 quantity squared. And that is equivalent to 923.245 meters. So 923.245 meters. So they should give you the same answer. Okay, so 923.45 meters. Okay, now it would be best if you're going to tabulate it. Okay, so we have here the line, the azimuth, then we have the length, we have the station, we have here the coordinates. Okay, so we have here the y and we have here the x. So line, let's say line AB, what is the azimuth of line AB? Where is that? Ito yung azimuth ni line AB natin. We have 50 degrees, 52 minutes, 34.65. And the length of AB is 923.245 meters and station A. Okay. Then for the coordinates of A, we have for the y-axis, we have 10,035.65. Then for the x, it is 10,866.262. Okay, and you should do the rest. So I hope by now you already know how to determine your coordinates using the given data or vice versa.